process-oriented period. The popularity of information processing as a means to understanding and explaining skill development began to increase around the time from the 1970s to the 1980s. The initial information processing theories were born from the first use of computers around the time just after World War II, and then later developed by psychologists. A notion that the brain acts like a computer, inputting information, processing it, and selecting an appropriate movement response as output. In actuality, however, the information systems models include a more complex interplay between the processing of perception, decision-making, the selection of specific motor programs, transmission of information, and intrinsic and extrinsic feedback. The figure details these associations. The most recent of theoretical frameworks to emerge has been the ecological perspective. This perspective relates the development of specific skills with regards to the relationship between the individual, the environment, and the task being performed. It suggests that to understand the development of motor skills, all of the elements, the individual, environment, and task, must be considered. In some way, each of the elements play a role in development. Some may play a larger role than others in specific tasks. The dynamic systems approach is one of two branches of ecological theory that deals with motor control and coordination. Dynamic systems theory is based on the work of Bernstein from 1967, who wrote about the physical and chemical constraints to behaviour. Behaviour is said to be self-organising and arising from the interrelationships between the constraints applying to the individual, the environment, and the task. The development of a particular behaviour relies on the mature relationship between all of the factors in the system involved. The systems relating to task competence are performance demands, movement pattern formation, and degrees of freedom. The individual systems include anatomical and growth factors, physiological factors, mechanical factors, and perceptual motor factors. The environmental systems consist of the opportunity to practice, encouragement and motivation, instructional cues and context within the environment. Each system, however, may interact at a different rate. For example, the individual begins to walk when all of the systems involved reach a certain point. Only when the slowest of the systems reaches the point of readiness can the individual walk within that particular environment. It may be that the child has all the attributes to walk, though does not have the strength to propel themselves, an individual constraint. Not until the child develops this strength can they walk. One of the major differences to previous developmental theories is the way in which the dynamic systems theorists explain the rate of development. Previously, development has been seen as and explained largely as linear and continuous. You first crawl, then walk, then run, with limiting time frames relating to chronological age ranges. From the dynamic systems perspective, the development of an individual over time may not, however, be smooth or progress in order of complexity. The dynamics of change occur due to the influence of rate limiters and rate affordances. Both are unique to the individual, task, and environment. The rate limiters hinder development, and the affordances promote development or change in the system. Using the development of walking as an example, several systems are required to be in interaction and controlled to perform the skill, including vision, balance, strength, motivation, structural and cognitive and environmental, etc. The four main components of information processing models then are sensory input, the reception of perceptual information, the interpretation and decision making, and the overt motor response. Each component is mediated by attention, memory, processing speed, and programming. In general, as children progress towards adulthood, they are able to process more information in a shorter time period. Attention has therefore been a focus as the major influence and limitation on the information processed. As children mature, they are able to process increasing amounts of relevant information. Young children focus on one stimuli and are easily distracted. Older children attend to too much information, some of which is irrelevant. Early adolescents attend to the relevant information in complex situations. The rate at which information is processed can be measured by reaction time, which usually improves with increasing age towards adulthood, but subsequently declines in old age. Within the dynamical systems example here, each of the smaller figures are example of individual systems, e.g. balance, strength, motivation, etc., leading to a mature behaviour of walking. Note that the rate is not linear and in some cases discontinuous. Walking is not mature until all systems are ready. This is just an example, and there are multiple systems involved in complex movements. When we talk about motor development, we are referring to a lifespan process. You are continually developing or changing throughout your life. Development equals change. In order to easily explain movement behaviours, we sometimes group them into stages or age periods. This is for convenience only. It doesn't apply when we think about dynamic systems theory.